Okay, Assalamualaikum and hi guys. So in this video, we will continue our lesson on our next subtopic for topic electricity and magnetism, which is magnet and current. So I already posted the slide last week on Teams. So I hope you guys can pre-read before you watch this video. Alright, so quick recap. So please pause your video and try to answer this question without refer to your notes. Alright, so this is from our last subtopic. Okay, you may pause now. So this is the answer for the quick recap from the previous class. So for the first learning objective, so we have magnetic effect of a current. So you have to know at the end of the class the methods of making a magnet, demagnetizing a magnet, so which we already learned from the simple phenomena of magnetism. So the new one is the magnetic field around a current carrying straight wire and a solenoid. So the variation in magnetic field strength around a current carrying straight wire and a solenoid, and how the magnetic field from a straight wire or solenoid is affected if the current is increased or its direction change. Alright, so the first one, magnetic field around a wire. So a wire, which means a straight wire. So if an electric current is passed through a wire, a weak magnetic field is produced. Okay, remember, if the electric current passed through a straight wire, weak magnetic field is produced. So the field has this feature. Number one, the magnetic field lines are circle. The field is stronger close to the wire. So macam mana kita nak tahu dia strongest ke tak? So bila dia dekat dengan wire, the magnetic field line tu dia rapat-rapat. So maksudnya dekat situ strongest magnetic field. Alright, so the third one, increasing the current, we will increase the strength of the magnetic field. Alright, so for this situation, magnetic field around a wire, so you have to remember the right hand grip rule. So where you can imagine gripping the wire with your right hand so that your thumbs points in the conventional current direction and your other fingers then points in the same direction as a magnetic field line. So conventional current is a current that flow from positive terminal to negative terminal. Okay, so here we have two symbols that you have to remember. So the first one, the circle with dot inside it. So it means that electric current out of the page, which means you pointing your thumbs out of the page and your other finger pointing on the anti-clockwise rotation. So the other symbol is the circle with the cross inside it. So it means that the electric current into the page. So which means you pointed your thumb into the page and the other finger will show the direction of clockwise rotations. Okay, beside the straight wire, so now we want to determine the magnetic field from a coils. So there are two types of coils, which is the one on the right is a single turn of wire. So which means dia ada satu gelong wire saja, and on the left we have a long coil with many turns and it is called a solenoid. Okay, so a current produces a stronger magnetic field if the wire flows in is wound into a coil. So the diagram below show the magnetic field pattern produced by two current carrying coils. Alright, so here come the important part on understanding a solenoid. Okay, so solenoid ni macam saya cakap tadi, a long coil of wire carrying an electric current. So kalau tak ada electric current, so maksudnya dia tak boleh nak produce magnetic field from the coil. So mesti wajib bulu gunnah kena ada electric current. Okay, so the magnetic field is similar shape to that around a bar magnet. Okay, dekat sini maksudnya pattern of magnetic field tu similar kepada pattern of magnetic field around a bar magnet. So macam mana pattern magnetic field dekat bar magnet? Macam tu jugalah, sama macam dekat solenoid. So kita ada bahagian north pole and kita ada juga bahagian south pole. Macam mana nak tentukan? Kita akan tengok lepas ni. Alright. So the strength of magnetic field can be increased when we increase the electric current, and number 2, when we increase the number of turns in a coil. So lagi banyak coil, lagi kuat the strength of magnetic field. So here we come. How can we determine the pole of the solenoid? Kan dia sama macam bar magnet. So kalau bar magnet, kita dah tahu dah which one is north, which one is south. Tapi untuk solenoid, kita kena tentukan sendiri. Okay, so macam mana kita nak tentukan? Kita tengok dekat ayat sini. The field produced by a current carrying coil has this feature. Okay, so the field is similar to that from a bar magnet, and there are magnetic poles at the end of the coil. So maksudnya dekat hujung solenoid tu dia ada poles dia yang tersendiri. So sama ada dia north pole dekat bahagian kanan ataupun south pole, itu kita akan determinekan by using the rules. Okay, so increasing the current increase the strength of the field, and the last one, increasing the number of turns on the coil increase the strength of the field. Kalau ada satu coil je, dia tak cukup kuat macam dekat solenoid yang ada banyak turns of coil. Okay, so rules apa yang penting dekat sini adalah right hand grip rules. Okay, so imagine gripping the coil with your right hand. Okay, so the fingers points the conventional currents. So maksudnya selain daripada thumbs, dia akan point in the conventional current, and your thumb then points toward the north pole of the coil. Okay, so boleh tengok dekat gambar sebelah ni. Alright, so kita continue macam mana nak tentukan the north and south pole. Okay, so bayangkan kamu genggam coil tu mengikut arah current arrow warna pink tu. Okay, so kita genggam solenoid ikut arah current. So jari kita ke bawah, so thumbs kita menunjukkan north pole. So maksudnya north pole di bahagian kanan, and the other hand is south pole. Okay, cuba untuk gambar yang kedua. Kita genggamkan coil, so menghala ke penjuru bahagian kiri. So north pole ke bawah and south pole ke atas. Alright, seterusnya menghala ke penjuru bahagian kiri juga, kiri atas. So the north pole will be pointing downward, and the south pole will be pointing upward. So the other way. Alright, so for now, imagine that the direction of current is changed. Okay, so kita bayangkan from the first picture, so the current now flow ke bawah. So sekarang ni kita cuba terbalikkan the current pointing kepada atas pula. So kita gripkan dia, jari kita menggenggam ke atas. So the north pole will change So North Pole tu dia takkan duduk dekat bahagian kanan dah, tapi dia akan pergi ke kiri. Okay. So dekat sini, we can make a conclusion that when we change the direction of current, we will change the direction of magnetic field line. So there are many methods of making a magnet. Okay, so salah satu daripadanya yang kita dah belajar, hammering, current and whatsoever. So now we focus on a solenoid and current. Okay, so first step, a steel bar has been placed in a solenoid. Okay, so when a current pass through the solenoid, so maksudnya ada current dalam solenoid, the steel become magnetized. So make the magnetic field much stronger than before. So when the current is switched off, the steel stay magnetized. Sebab apa? Sebab steel is hard to magnetize but hard to demagnetize. So that's why dia punya magnetization dia tu stay. Okay, so next, we wanted to demagnetize a magnet. So daripada magnet tu dia magnetize, kita nak buang dia punya sifat kemagnetan tu. So macam mana? Okay, so bayangkan kita ada magnet and a coil. Also a solenoid and AC current. Okay, so a magnet is slowly being pulled out of the solenoid. So maksudnya magnet tu sekarang ada dekat dalam solenoid. Lepas tu kita slowly being pulled out of the solenoid. So the alternating current is passed through the solenoid. Okay, AC current flow backward and forward continuously. Maksudnya daripada positif ke negatif, daripada negatif ke positif, forward and backward. So produce a magnetic field which change direction rapidly. So bila dia change direction rapidly, dia akan cut the magnetic flux. So they throw the atoms or domain in the magnet out of the line. So bila dah throw the atoms out of the line, domain tu dah tak tersusun, jadinya we demagnetize a magnet. So magnet tu dah tak ada magnetization. So that is all for this video. So on our next subtopic, we will learn about electromagnet and also magnetic force on a current. Okay, see you guys on our next video. So don't forget to subscribe.